Good morning, all. Today we are going to learn about glycolysis and its significance. So, glycolysis is a common oxidation pathway of glucose where glucose is completely oxidized to pyruvate through a series of enzymatic reactions. So, when you consider the location of glycolysis, so glycolysis takes place in the cytosolic region. Okay. And when you consider the term glycolysis, so we need to understand, so it is all about oxidation of glucose. So oxidation of glucose or splitting of glucose, okay, into small molecules. At the same time, it releases energy in the form of ATP. Okay. So the entire pathway, the reaction pathway of glycolysis can be considered under two different phases. So there is an alternate name for this pathway, which is proposed by Emden Mayer of Parnas. Hence, this pathway is also named as EM pathway. So this EM pathway has two different phases. So one is preparatory and the other one is payoff phase. So first we need to understand what is preparatory and what is payoff phase. So preparatory phase, in a simple terminology, we can understand that it prepares glucose molecule for its oxidation purpose. So in a simple way, we can understand that it is also considered as energy consuming reactions. So all these reactions, so the first five reactions, so which comes under glycolysis, so is considered as the reactions of preparatory phase. And when you consider the starting substrate of glycolysis, so we all know that starting substrate of glycolysis is glucose. And this glucose first reaction, it undergoes phosphorylation, where glucose gets phosphorylated to glucose 6-phosphate with the presence of enzyme that is hexokinase. Hexokinase is a non-specific enzyme, whereas glucokinase is a specific enzyme where it phosphorylates only glucose, whereas hexokinase phosphorylates any hexose sugar. And this hexokinase, when it phosphorylates glucose or any other hexose, so it gets phosphorylated. So glucose gets phosphorylated to glucose 6-phosphate. And here ATP is utilized. I mean, ATP is involved in this reaction. So one molecule of ATP is involved in this reaction. So where ATP is considered as a phosphate donor, and phosphate which is present in the ATP, so which is esterified in the glucose. So glucose is converted, or glucose is phosphorylated to glucose 6-phosphate. So that is all about the phosphorylation of glucose. Ultimately, we get glucose 6-phosphate, and followed by the phosphorylation of glucose. So glucose 6-phosphate, which in turn undergoes aldo-keto isomerization. So otherwise, simply we can consider it as isomerization, where the aldo sugar is converted to keto sugar. That means glucose 6-phosphate. So it's a sugar phosphate, but it is aldo sugar. So this aldo sugar is considered to converted to keto sugar. So glucose 6-phosphate is converted to fructose 6-phosphate, which is catalyzed by phosphohexoisomerase. So the ultimate function of this phosphohexoisomerase is condensation. So not exactly. We can consider it as isomerization. So isomerization of glucose into fructose. And it is not an energy yielding reaction. Whereas the third reaction is considered to be the conversion of fructose 6-phosphate, so to fructose 1,6-phosphate. Again, the fructose 1,6-phosphate, deformed fructose 1,6-phosphate. So it is a keto sugar. So after the conversion of aldo keto isomerization, so we get fructose 6-phosphate. And this fructose 6-phosphate further it undergoes phosphorylation with the presence of again one molecule of ATP, so that it gets converted to fructose 1,6 biphosphate or diphosphate. So ultimately we get fructose 1,6 biphosphate, and this fructose formed fructose 1,6 biphosphate is again cleaved by aldolase. So aldolase is the enzyme, so where it cleaves this fructose 1,6 biphosphate into two different compound. One is glyceraldehyde 3-phosphate, the other one is dihydroxyacetone phosphate. So glyceraldehyde 3-phosphate, we know that it is aldotriose, and the other one is ketotriose, and both are interconvertible, which can be readily undergo interconversion, so with the help of triose phosphate isomerase. Then the further reactions, I mean the glyceraldehyde 3-phosphate, so the reactions considered from the glyceraldehyde 3-phosphate all are considered to be the reactions that comes under payoff phase. So whatever these reactions discussed now, so all these reactions can come under the preparatory phase. So moving on to the payoff phase of glycolytic reactions, payoff is nothing but energy yielding reaction. So which gives energy mainly in the form of ATP. So under the payoff phase, so another 5 reactions are included from we can consider from reaction 6 to reaction 10. So all these reactions which are considered to be payoff phase reactions of glycolysis. So here, when glyceraldehyde 3-phosphate is undergoes the payoff phase reactions. So where here this conversion of glyceraldehyde 3-phosphate is mainly catalyzed by glyceraldehyde 3-phosphate dehydrogenase, and ultimately it is converted to 1,3-biphosphoglycerate. So here NAD is involved in this reaction, and this NAD, 2 NAD is involved in this reaction. So ultimately when it gets oxidized via electron transport chain, ETC, so when we know 1 NAD, when it gets oxidized, ultimately releases 3 molecules of ATP. When 2 NAD is involved, it releases 6 molecules of ATP. So this is the first energy yielding reaction. And so the conversion of glyceraldehyde 3-phosphate to 1,3-biphosphoglycerate liberates 6 molecules of ATP, and followed by the further conversion, that is conversion of 1,3-biphosphoglycerate to 3-phosphoglycerate in the presence of, that is phosphoglycerate kinase. So phosphoglycerate kinase, again, it's a enzyme which catalyzes the substrate level phosphorylation, so where ATP is formed at the substrate level, okay, so without entering the ETC. So here 1,3-biphosphoglycerate, so again it is converted to 3-phosphoglycerate, so where 2 ADP molecules gets phosphorylated, so it results with release of 2 ATP molecules, and this reaction is considered to be second energy yielding reaction of glycolysis. And further the reaction continues with the intermediate, that is 3-phosphoglycerate, where it is converted to 2-phosphoglycerate, again 2-phosphoglycerate, when it undergoes dehydration, so it can be converted to phosphoenol pyruvate, and the final conversion of phosphoenol pyruvate to pyruvate, which is catalyzed by again pyruvate kinase. So again it's a example for substrate level phosphorylation, where it phosphorylates ATP at the substrate level, and 2 ADP gets phosphorylated, so it results with release of ATP. Okay, so from reaction 6 to reaction 10, so all these reactions of glycolysis, so which can be considered as payoff phase. So we are clear now what is a preparatory phase of glycolysis and what is payoff phase of glycolysis. Considering the energetics of glycolysis, so energetics of glycolysis, under energetics, 2 things that we need to consider. One is energy yielding and the other one is energy consuming. So first we discussed about energy consuming, and later we discussed about energy yielding reactions. So energy yielding reactions, as I mentioned, so under the payoff phase, so the first energy yielding reaction is conversion of glyceraldehyde 3-phosphate to 1,3-biphosphoglycerate, where it produces 6 molecules of ATP, and the next reaction, that is 1,3-biphosphoglycerate, is converted to 3-phosphoglycerate, where it produces again 2 molecules of ATP. Again, it's a substrate level phosphorylation, And even the last reaction is also considered to be substrate level phosphorylation, and it is also an energy yielding reaction. So therefore, the total number of ATPs produced, so under the energy yielding reactions